Today's lesson is 12.3, the quadratic formula. And for the quadratic formula, it's important to note that we can use this for any quadratic. So that's why it's very nice. Now, some of you may be asking, well, if we can do this for any quadratic, why do we need to know how to complete the square? That is a skill that you will need next year when you're working with circles and a few other things. So you do need to know how to complete the square. There will be test questions that tell you you have to do this one by completing the square. So for a polynomial in standard form, notice we're in standard form, ax squared plus bx plus c. Note we're set equal to 0. We have this little formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And so now let's just dive in and start an example. Our directions are to find the solutions. We're going to be finding the solutions. Let's look at this one. Something to note and always ask is, are we set equal to 0? And here we are not, so we have to subtract the 21. And I get x squared minus 4x minus 21 equals 0. Now we have to decide what is our a, what is our b, what is our c. A is in front of our x squared term, and here we have a 1, so a equals 1. B is in front of our negative 4. B is the number in front of the x, which is negative 4. So b equals negative 4. C is a constant. C is negative 21. And now let's plug them into our formula. We have negative, now notice b is negative, so negative negative 4 plus or minus square root b squared minus 4ac all over 2a. That's how we plug it in. Now we can simplify. On the top, we have positive 4 plus or minus the square root. Here I have 16, negative 4 squared. Negative 4 times 1 times negative 21, that's positive 84. 16 plus 84 is 100. Now it's really important that we do this inside piece correctly. A negative times a negative gives us a positive 84. And this is all over 2. Continuing, 4 plus or minus 10 over 2. And we can split this now into two problems. 4 plus 10 over 2, 4 minus 10 over 2. This gives us 14 over 2. This gives us negative 6 over 2. So our answers are x equals 7 from 14 over 2 and negative 3 from negative 6 over 2. I want you to go ahead now on example 2. So go ahead and pause the video, try example 2, plug them in. First question, are we set equal to 0? Yes, we are. Now we have to identify our A, B, C. A is the number in front of x squared, B is the number in front of x, C is the constant. Let's write it off to the side. A equals 4, B equals 7, C equals negative 15. Plugging it into the quadratic formula, negative b plus or minus b squared minus 4ac all over 2a. Oh, there I did the 2a in my head. That should be a 4. Let's go ahead and simplify this. -7 plus or minus the square root. I have 49. Negative times a negative, that's going to give me a positive. $240. That gives me 289 over 8. 289 is a perfect square. We get 17, and now we can split it into 2. -7 plus 17 over 8. -7 minus 17 over 8. This gives us 10 over 8, -24 over 8. We get x equals 5 over 4 and -3. Last one of this type of question. Identify, are we set equal to 0? Find your a, b, and c. A is in front of the x squared. So a here is -1. B is in front of the x, so it's -8. Let me make that bigger. C is 2. Go ahead and plug it in. -b plus or minus b squared. Make sure you put that in parentheses. Minus 4ac all over 2a. Simplifying, we get 8 plus or minus. On the top, 64. Negative times a negative times a positive. That's going to be a positive plus 8. So that's 72 over -2. This is not a perfect square. So here we have to make our little tree. I have a pair of 6s and only one 2. So the 6 will come out and the 2 will stay in. So again, I got 6√2. I had a pair of 6s. The 2 is by itself, so the 2 stays inside. I want us to look at all 3 of those numbers. All 3 of those numbers can be divided by 2. And the negative, we're just going to bring up to the top. So this is -4 plus or minus. Now if I bring the negative to the 6, it's going to change it to minus plus. But that's the same thing as plus or minus. So I just kept it as plus or minus 3√2. This means x equals -4 plus 3√2 and -4 minus 3√2. You can also keep it together like that. Now we have all these methods. And so now we're going to look at 4 different examples and see which method would we use to solve each. So first, let's make a list of the different methods we have. We can solve by square rooting. We can solve by factoring. We can solve by completing the square. And the last one is the quadratic formula. So let's look at example 1. Pick one of those 4 and justify why we would use that one. Looking at it, I notice that my A value is 1, and it might be easy to quickly try to factor it. So this would be x and x to multiply to 12, 1 and 12, 2 and 6, 3 and 4. I'm going to try 2 and 6. I want them to multiply to a positive 12. And then when I do my underneath rainbows, get a negative. So it's going to be negative, negative. And it factors. And this would be the easiest situation here because now I know that x equals 2 and 6. So here the easiest method would be to factor y. It's factorable. Let's write an is there. It is factorable. Looking at example 2, I notice that I don't have a bx term. Notice up here we had an 8x. Here I only have the x squared and the constant. So since there's no bx term, I can go straight to dividing by 169 and then taking the square root. So here I would just do square rooting. Why? I would say no bx term. Or you could say, since there's no bx term, b equals 0. For 3, I notice that my a is 1. Looking at it, could I quickly factor it? I want the same signs. They're going to both be negative. 6, I can do 1, 6, 2, 3. If I put 2 and 3 here, I'll get negative 5x. If I put 1 and 6 here, I'll get negative 7x. So we can't factor it. Can't do it by square rooting. Now I'm going to think about completing the square. I would complete the square on this one. Why? My a is 1. My b is even. I can easily split this into 2, add something to both sides in order to turn it into that square rooting type of problem. So again, y, my a equals 1, and the b is even. For 4, I could check if it's factorable, but it's not as quick as number 1. I have a bx term, so not using square rooting like example 2. My a is not 1, so I would have to divide everything by 5, which would make a mess in order to complete the square. Here I would use the quadratic formula. Why? A does not equal 1, and it's not factorable. A question you may be asked, moving on to a different little topic or type of question, is how many real solutions does the following have? So, looking at the quadratic formula, well, first let's talk about what is a real solution. A real solution means that we are not taking the square root of a negative. So we don't have the square root of a negative. If I have the quadratic formula, when would I be taking the square root of a negative? Well, I'd be taking the square root of a negative when for the second line, b squared minus 4ac is less than 0. So if this piece is negative, if it's less than 0, it's not going to be real. So if we have this situation, we will have no real solutions. If this piece is positive, then I have the square root of a positive number. We can do that. I would then have negative b plus that number and negative b minus that number. So here I would have two real solutions. If we're equal to 0, if this piece right here is equal to 0, remember, we're always focusing on this piece. Then I have the square root of 0 is 0, so I have plus 0, and I have minus 0, which is the same thing. So I would have one real solution. Now this piece has a name. We call it the discriminant. So if the discriminant is positive, we have two real solutions. If it's negative, no real solutions. If it equals 0, we have one real solution. So let's apply this. The first example, find your A, B, and C. If you want, you can plug them into the whole quadratic formula, or you can just look at the discriminant. I'm just going to look at the discriminant. B squared minus 4AC. Plug that in your calculator or do the math. I get negative 143, which is less than 0. No real solutions. For example 2, go ahead and find your ABC. A is in front of our x squared term. A is 1. There is no bx term. Since there's no bx term, b is 0 because it doesn't exist. And c is negative 15. Go ahead and plug this into your discriminant. We get 0 squared minus 4ac, which is 60. This is greater than 0, so we will have two real solutions. And yes, I need to see this work on your paper to prove why you're saying how many.